Welcome students to your favorite, finest and more conceptual producer classes as PSC, and we are in IIT Foundation course, and there are different type of course actually. There is IIT Foundation course and numericals, a basic series, the numerical king series for 11th standard, for 12th standard, and for another series that is IE Irodov, as well as the concepts of 11 and 12. And you must go to the playlist and can check all the lectures given one by one. So today we are in IIT Foundation course. This is ICSE-10, and for the next within a week or 2 weeks we are go through a particular chapter that is related with CBSE 10. And so it is about IIT Foundation course. It is based on class 10, that is it may be ICSE or CBSE syllabus, and I completed all the concepts as well as relative to the motivations of IIT Foundation course. Okay, so for today's class, this is circular motion and chapter 1, and it is for ICSE and circular, and this is motion. So what is about circular motion and what are the different topics related with it? So when we say that the circular motion, then you take into account that the different circular motion related with our environment, since physics is the study of nature, so you have to find out all the events are occurred in our society, in our nature. Okay, so first of all, students, think about merry-go-round. What is about merry-go-round? What is about giant wheel? What is the metallic structure? Metallic structure in merry-go-round, it is actually a platform of metallic platform that revolves in a circular path. So what is about uniform circular motion? So first of all, the key points are uniform circular motion, and the next one is a difference between uniform circular and uniform linear motion, and the next one is a centripetal force, and the final is a direction of velocity in circular motion, not center of mass, not cm, it is a circular motion. Okay, so first of all, students, what is about circular motion and what is the definition of it? So let's start that particular lecture. So first of all, what is uniform circular motion? Uniform, when, so the definition is when a particle, not a body, if it is extended body, then we take into account in a system of particles. So when a particle moves in a circular path, in with constant speed. When a particle moves in a circular path with constant speed, then this type of motion is called circular motion. So the definition is when a particle moves in a circular path with constant speed, then this type of motion is called circular motion. So what is the basic property? What is the basic property of a circular motion? That is, the speed must be constant. So first of all, students, you have to know what is the speed and what is velocity. So speed plus direction. Speed plus direction, this is equal to velocity. Means the rate of change of displacement. So we can write as v vector equal to s vector by t, or v equal to s by t. So when v equal to s by t, that is called speed, and when we add a direction, then we can say that this is velocity. So it is velocity and this is speed. Rate of change of distance is called speed, and rate of change of velocity is called rate of change of displacement, sorry, this is called velocity. So speed plus direction equal to velocity. When a particle moves in a circular path, and so this is a circular path, and this is the center of the circular path, and a particle, not extended body. When a body is said to be a particle or extended form, if students, suppose this is a chalk and all the constituting particle, that is the dust of this chalk, we can say this is a particle, or we can consider this is a particle with respect to another body when it is a very much negligible with respect to some physical quantity. Suppose, is moon is a particle, is earth is a particle? Yes, earth is a particle with respect to sun. A moon is a particle with respect to earth. So we can consider a particular body, it is extended or it is a particle with respect to some other things comparable with that particular two objects. Okay. So this is a particle. Suppose this is chalk, and this chalk revolves around the circular path with this center. And students, think about what is circular motion and what is rotational motion. What is rotational motion? I draw a motion, and where we can depict a particular cycle. So when that cycle moves in particular direction, then we can say that it is linear motion. And if the cycle is in constant velocity, then we can say that this is uniform linear motion. If the direction as well as the speed remains constant, then we can say that uniform linear motion. But the field of the cycle is a rotational rotation. But if we take a point or a mud particle that is stick with that particular field of the cycle and it is moved, then we can say that the motion of this particle is uniform circular motion. If we tie a stone with a string and rotate or revolve with that particular concepts, then we can say that this particle revolves in a circular path. So this is a circular path, and at that point the particle moves along this direction. But at that point the particle moves along this direction, and at that point the particle moves along this direction. If we take at that moment, it is along this direction, and we can clearly specify that particular concepts with east, west, north, and this is south. East, west, north, and south. So students, if we cut this circle with quadrant, this is first quadrant, and this is second, and this is third one, and this is fourth one. So we consider, if we divided this with the fourth quadrant, then at the position A, B, C, and D. At position A, the direction is along north, but at position B, the direction is along west, and at that moment it is along south, and at that moment it is east. So we can clearly see that at each and every quadrant, when it is crosses that particular quadrant, its direction changes along a specific direction, and at the meantime we can see that at that point the direction is along this direction, at that point this is along this direction, at that point this is along this direction, and at that point this is along this direction. So constantly its direction changes. So what is the main basic concepts? The speed remain constant. Speed equal to constant. In circular motion, speed remains constant, but velocity, what is about velocity? Velocity, yes, it is changes. So uniform means it subtend a particular angle with particular interval of time. This is called uniform. Uniform circular motion, speed remains constant, velocity changes. This is called uniform. So when a particle moves along a circular path with constant speed, but its velocity changes, then we can say that this type of motion is called uniform circular motion. So this is uniform circular motion, and we can explain, we can give some example. So take a different example related with uniform circular motion. First of all, students, take example number one. Within an atom, an electron revolves around the nucleus. An electron revolves around the nucleus. Within an atom, an electron revolves around the nucleus. So like that, if we consider this is a proton and this is neutron particle and this is electron, so this electron revolves with a constant speed around the nucleus. So this is an example of circular motion. So there is an attraction force between the proton and the electron, and this is called electrostatic force. Somehow it is electric force associated with proton as well as electron. So it is there is a force required for that circular motion, and we can explain that particular concept related with the three, that is centripetal force. So what is about centripetal force? Centripetal force, when a particular body, suppose there is a chalk. What is about the chalk? The chalk is at rest. Okay. So if we change that particular state of motion, then it required a particular force, and if we applied a force, then chalk changes its state of motion, that is within state it goes into another, that is in motion. So a chalk, when we change the state of a body, we must apply a force. So when that electron moves along this direction, it is also required a force, which is called centripetal force. Why it is centri? Centri means it is a center shaking. It is a center shaking force. It is a center shaking force. So the force acts along the center, and this is called centripetal force, and this force FC, central force, equal to mv square by r. This is the equation. Don't go for the proper explanation of this force. Just as students think about a force when a body is in circular motion, that it requires a particular force. This is called centripetal force, and the expression of the central force is mv square by r. What is about v? This is velocity with which the electron revolves around the nucleus. And what is about r? This is the radius. We know that this is the radius. So this is radius, and this is the mass of the electron. mass of the electron, and this is velocity with velocity. At that point the velocity is along this direction, at that point this is, so at a particular point its velocity is different. So Fc equal to mv square r, this is the expression of centripetal force. So when what is about next, we can define centripetal force. Next definition is, so this is an example, when in an atom an electron revolves around a nucleus. This is a type of circular motion, and we go through a different example. Okay, so for then the topic is, what is centripetal force? What is centripetal force? The question is, what is centripetal force? And last of all, students, I revise all the definitions and the related terms. What is centripetal force? The next question is, what is centripetal force? So force, a force required to move a particle, move a particle along a circular path. A force required to move a body along a circular path is called centripetal force. And it is like that a body, if we change the position, if we change the pitch along this direction, then we can apply a force along this direction, and it can accelerate along the direction of force. But so this is a centripetal force, and the equation is, if we want to calculate the amount of force required for this radius with a velocity of v and moving with a mass this, then the equation is this one. So you can just write down the equation, don't go through the explanation or derivations of this equation, mv square by r, just then you can solve the numericals. So force required to move a particle along a circular path is called centripetal force, and this is center shaking force, or we can say that this is central in nature. This is central, CENTRAL, central in nature. So this is centripetal force. And first of, what is uniform circular motion? We know that what is uniform circular motion, and the second one and the third one is also completed, that is what is about centripetal force. And we can complete the example, and then we know the difference between a central circular motion and a linear motion, uniform linear motion. So the second example is Earth revolves round the sun. Earth revolves around the sun. So this is sun, and is this a circular path? It an elliptical path. We know from the 9th standard that Kepler's law. Okay, what is about Kepler's law? Each planet move in an elliptical path. This is called ellipse, and this is, on an average we can take it is circular, but actually this is an ellipse. So Earth revolves around an elliptical path with the sun at one of its foci. What is about foci? Since this is the ellipse, so there is two center, and since there is a circle, so it exhibits a one center. So don't go for that concept. Just think that sun, then Earth revolves around the sun with a circle. Okay, so this is the radius of the circle, and if m is the mass of the earth, then we can say that there is an attraction force which is center seeking also, and this is Fc equal to m mass of the earth suffix c and v square with which the earth moves along this direction, so this is v square by r. Okay, so this is the expression, but this force is, this centripetal force, we can say that this is gravitational force. Gravitational, T-I-O-N-L, gravitational force. So what is about gravitational force? What is about electrostatic force? All are the forces that provides that particular centripetal force to move that particular body in a circular path. And the next one is, we can say, similarly we can say, if this is earth and this is moon, then we can say that the moon revolves around the sun, also is an example of circular motion, and here also the gravitational force is provided, that centripetal force. Okay, and so next example, a particle or a body, a particle, this is a rotary, and a cyclist move along this direction, so motion of the cyclist within a rotary is an example of circular motion. And here the frictional force, here this force is the frictional force between the tire and the ground. So the frictional force between the tire and the ground provide the centripetal force. So students, you can write a table, and first of all students, take 1, 2, 3, 4. 1, the centripetal force, what type of force, and take an example. Suppose earth revolves around the sun, so the centripetal force is gravitational force. Then in merry-go-round, so the centripetal force is the tension force. Okay, if a body, suppose this man tied a stone with a string and revolved around along this direction, so here the tension force, so it is an example of circular motion. A tension force provided the centripetal force. Here a frictional force between the tire and the ground provide the centripetal force. If electron revolve around the nucleus, then the electrostatic forces provided the centripetal force. So this all are the example of uniform circular motion. And what is about uniform circular motion? We already know that with constant speed, when a body moves, that is the it can subtend at equal angle with equal interval of time, then we can say that this is circular motion. And the next one is basic difference. What is the basic difference? Basic difference between uniform linear motion and uniform circular motion. So what is about linear circular motion? First of all students, take some points. Speed, yes, speed is constant. Speed is constant in uniform linear motion. Yes, speed is constant. And uniform circular motion, velocity also remain constant. So in uniform linear motion, speed is constant as well as velocity is constant, but uniform circular motion, velocity changes. Since velocity changes, So we can say that this is accelerated. What is acceleration, students? What is acceleration? So the rate of change of velocity is called acceleration. Since velocity changes, then accelerated motion, and it is unaccelerated. So this is the basic difference. Here the speed is constant, here the speed is constant. But is velocity constant? But here the velocity changes at each and every point. So if we take a tangent at that particular point, tangent, then this gives the direction of velocity at that point. So this is unaccelerated and this is accelerated since velocity changes. So this is the basic difference between uniform linear motion and uniform circular motion. Okay. So force associated with linear motion, we can simply say that a force. But in this type of the force related is a specific name. This is centripetal force. Centripetal. Why it is centripetal, students? Because it is always directed at center. Earth revolves around the sun. This is also central in nature. So this is central force. This is also central force. And frictional force, gravitational force, all are central force. But frictional force, it may be if we walk on that particular ground, then you can say that a frictional acts. This is not central in nature, but centripetal force is a basic property which is always directed to the center. Okay. So this is the basic difference. So students, again I repeat, what is uniform motion? When a particle moves in a circular path with constant speed, then we can say that this is circular motion. What is the difference between the basic difference between a speed and velocity is constant, but here velocity changes, unaccelerated motion, and this is accelerated motion. What is centripetal force? A force required to move a body in a circular path. This is called central force, and the direction of velocity, we know that at each and every point its velocity changes. Okay, so it is all about, students, the circular motion, and I think the concept is you grasp that particular concept related, and you also modified these concepts with your own thoughts. Okay, so let's the second topic is centrifugal force. What is about centrifugal force? For that you have to wait for the next class, and thank you. Stay with this channel, and last of all I say continue your study. That will be emphasize your problems, emphasize your thoughts. Thank you.